Hello guys! I'll start a series of videos of how to hack the ARP protocol and launch a man-in-the-middle attack to capture sensitive data. I want to start with a disclaimer. Do not use any of the information I teach you in this video and in all my other videos related to network security and ethical hacking for malicious activities. Launch the attacks shown in this course only on your network or on other networks that you have permission to access. Let's start with a short explanation of what ARP is and how it works. A good understanding of ARP is critical to deeply understand how this attack works. ARP, or ARP, stands for Address Resolution Protocol and is one of the fundamental protocols used in wired Ethernet and wireless networks. When a device wants to communicate with another device in a local area network, it needs both the MAC and the IP address of the destination. The user that starts the application on the source host uses only the IP address of the destination host. The destination MAC address remains hidden to the user. Just imagine that you want to ping a device on your LAN or you want to connect using HTTP, so the browser, to the local router or to other websites. In all these cases, you'll use only the IP address of the destination. If you are not a network engineer or a technical person, you wouldn't even know that there is also a MAC address involved. In a LAN, the packets go through a switch or an access point, and they take decisions based only on the MAC address. The switch or the access point looks for the MAC address of the packet in the packet headers and forwards it accordingly. Let's look at an example. I'll ping the internal interface of the router, which is the default gateway. Before launching the ping command, I'll start Wireshark to sniff the traffic. I want to see all packets that are being transmitted and received. I am starting Wireshark. Capture, Options, I am selecting the interface, Wi-Fi, and Start. Perfect. And I am pinging the default gateway, ping 192.168.0.1. Okay, it's working. As you can see, I've used only the IP address of the destination and not the MAC address as well. I'll stop capturing packets. If we take a look in Wireshark at ICMP packets, these are ICMP packets, and were generated by the ping command, we notice that there are both the IP and MAC address in the packet headers. Let's take a look at this packet. This is the source MAC address, the destination MAC address, the source IP address, and the destination IP address. Somehow, the source host should have found the MAC address of the destination. And here is where ARP comes into play. It works behind the scenes and finds the hardware address, also known as MAC address, of a host from its own IP address. Let's take a look again at the packets captured by Wireshark. And we notice these two packets. These two packets of type ARP. This is an ARP request packet and this is an ARP reply packet. The ARP request packet is nothing but a broadcast packet sent over the network to find out the corresponding MAC address of a given IP address, the destination address. We notice that this ARP request packet is destined to the broadcast address. The destination MAC address is of type broadcast. Being a broadcast packet means that it will be received by each host in the network. And the message says, who has 192.168.0.1? Tell 192.168.0.1 .103. .1 was the destination, so the IP address of the default gateway, and .103 the IP address of Windows. In plain English, it means what is the MAC address of 192.168.0.1 wants to know 192.168.0.103. Each host on the network has received the packet, but only the host with the IP address 192.168.0.1 has responded back with an ARP reply packet that contains its own MAC address. This is the ARP reply packet, and it says that 192.168.0.1, so the destination, has this MAC address. Now, the source host, which is the Windows machine, knows both the IP and the MAC address of the destination and can build and then send the ping echo request packets on the network. And we see in the packet headers both the IP of the destination given by the user and its corresponding MAC address found by ARP. This is the destination MAC address found by ARP. Now, after resolving the MAC address of the destination, ARP stores the mapping between IP and MAC in a table called ARP table for future reference. The subsequent communications with the same destination IP address can use the same MAC address from the ARP table. The source host will not repeat the process to find the MAC address of the destination. If you want to display the ARP table, you execute ARP-A both on Windows and Linux. This is the ARP table. You see the mappings between IP addresses and MAC addresses. For example, this is the mapping between the IP address of the default gateway and its MAC address found by ARP. If you want to delete the entries in the ARP table, you execute ARP-D on Windows. To run this command, you need administrative privileges. Now the ARP table is empty. So this is basically how ARP works. Now we'll take a short break, and in the next lecture, we'll talk about man-in-the-middle attacks and ARP poisoning.